What if our solar system's latest interstellar visitor is more active than we ever imagined? That's the question scientists are asking about 3I/Atlas. Only the third confirmed interstellar object ever seen, and it's already breaking the rules. For the first time, astronomers have detected a massive anti-solar tail, tens of thousands of kilometers long, streaming away from this cosmic traveler. This isn't just another comet. It's a messenger from a completely different star system. And what it reveals could change how we think about alien worlds forever. 3I/Atlas, discovered in 2025 by the Atlas Sky Survey in Hawaii. From the very start, it stood out as unusual. Instead of behaving like a typical water-rich comet, it displayed a faint halo with strange chemistry that puzzled astronomers. Early measurements hinted at large amounts of carbon dioxide and very little water, something that immediately suggested this object was born in a very different kind of solar system. To put this in perspective, we've only ever identified 3 interstellar objects: Oumuamua in 2017, Borisov in 2019, and now Atlas. Each one has completely changed the conversation. Oumuamua gave us mystery without a tail. Borisov was familiar, a comet spewing gas and dust. But Atlas? It's rewriting the rulebook. It's ejecting material, glowing strangely, and now even forming a tail unlike anything we expected. This makes Atlas more than just a curiosity. It's a direct sample of alien chemistry floating right past Earth. Imagine trying to learn about other solar systems without ever leaving our own. That's what interstellar objects allow us to do. They're cosmic messengers, carrying clues from faraway stars. These discoveries touch on questions everyone wonders about. What are other star systems made of? Do they form planets like ours, or something entirely different? Could these objects even spread life across galaxies? The possibilities are wide open, and every new observation brings us closer to answers. And just when astronomers thought they had Atlas figured out, new observations revealed a stunning twist. A massive tail stretching tens of thousands of kilometers, aimed directly away from the sun. The breakthrough came on August 27, 2025, when astronomers at the Gemini South Observatory in Chile turned the JWST instrument toward 3I/Atlas. They collected deep images across 4 spectral bands, U, G, R, and I. What those images revealed shocked the community: a teardrop-shaped anti-solar tail, about 30 arcseconds long, which translates to nearly 56,000 kilometers trailing behind the comet. This wasn't just a fuzzy glow. The structure was clear, a distinct extension pointing directly away from the sun. That's the key signature of solar radiation pressure at work, pushing fine dust particles shed by the comet into space. Why is this such a big deal? Because until that moment, observations from Hubble and other telescopes had shown only a vague, halo-like coma around Atlas. No clear tail. In fact, some scientists wondered whether it might never sprout one at all, making it more like Oumuamua than Borisov. The Gemini South data ended that debate in spectacular fashion. The detection of this anti-solar tail places Atlas firmly in comet territory. But it's still no ordinary comet. The length, faintness, and structure of the tail hint that Atlas isn't shedding water-rich ice in large quantities like comets in our solar system. Instead, its activity seems driven by carbon dioxide and other unusual volatiles. This discovery doesn't just tell us that Atlas is active. It gives astronomers a natural laboratory to study how radiation from our sun interacts with material from another star system. Every pixel in that Gemini image carries chemical and physical clues about an alien world's building blocks. But the surprises don't end with the tail. Digging deeper, astronomers have uncovered a cocktail of strange gases around Atlas that make it even more mysterious. The Gemini discovery added to a growing pile of unusual evidence. Even before the tail appeared, spectroscopic studies from powerful observatories revealed that 3I/Atlas was chemically bizarre. The James Webb Space Telescope, JWST, detected strong emissions of carbon dioxide, but found only tiny traces of water vapor. That's the opposite of what astronomers expect. Comets in our solar system are usually dominated by frozen water. Then, using the Very Large Telescope in Chile, astronomers found cyanide gas, CN, and even signs of nickel vapor streaming from the comet. Nickel is rarely detected in comets. and its presence here raises questions about how this object formed. What does this mean? One possibility is that Atlas formed in a part of its home solar system rich in CO2.